power of a product or quotient. All right, you can distribute an exponent only when multiplying or dividing. Multiplying or dividing. This is stuff we have already done. If I give you x squared y to the third power, don't do it, don't write it down, just look at it. What is x squared y all to the third power? X to the sixth times y to the third. Right. Now, these fractions are a little bit hard for me to see, so you may have to help me out a little bit. Does that say a to the 2/3 times b to the 3/2, all raised to the sixth power? Remember, when you raise a power to a power, what do you do to the powers? When you raise a power to a power, you multiply. That's back on the previous page at the top. Not when I multiply. So let's look at a to the 2/3 raised to the sixth. What do you do to those exponents? Tell me, what do you do to the exponents? You multiply them. So what's 2/3 times 6? 12/3, which is 4. So this is going to be a to the 4th. Then you have b to the 3/2 raised to the 6th. 18/2, which is 9. So a to the 4th times b to the 9th. Multiplying fractions is super easy. That's it. That's it. 2x to the 1/5 times y to the 3/5, all raised to the 5th power. My first question is, what do you do with that 2 out front? Is the 2 raised to the 5th power? Why is the 2 raised to the 5th power? Because, where is it? In the parentheses. Yes, because it's in the parentheses, so everything's raised to the 5th power. What's 2 to the 5th power? Do it on your fingers.
32.
Good. 2 to the 5th power is 32. X to the 1/5 raised to the 5th. X to the 1st, which is x. Good. Y to the 3/5 to the 5th power, which is, so what do I have? Y cubed. And there's your answer. Hey, smart board. You're doing good. I can't find any wood. Fake wood, but close enough.
It's the thought that counts.
It is the thought that counts. C. S to the 3/4 times t to the 1/4 raised to the 4/3. Where are you getting 12/12? Because 3/4 times 4/3 is s to the 1st, which is s. Then we have t to the 1/4 times 4/3, which is 1/3. Right, 2/6, which simplifies to 1/3. Question. What's raised to the 1/3? The s or the t? Just the t. Just the t. All right, you're doing great. Let's keep going. X to the...
It'd be 6/15. So.
No. Yes.
Not 3/5. 2/5. Hey, let's have a mini fraction lesson. shall we? You guys make fractions too hard. 3/5 times 2/3. Here's what you guys are saying. Nothing wrong with that. That's correct. But then you simplified, right? And you divided by 3. And you got, right? Why don't we just divide the 3 out right there?
Whoa. Whoa.
Didn't I divide the numerator by 3 and the denominator by 3? No, but I'm just trying to show you that math's not as hard as sometimes you make it out to be. I know, 2/5. Uh-huh. So, x to the what? X to the 2/5. Now let's what's y now? This is y. This is 3/4 to the 2/3. Don't do 6/12. Do it. Why is it a half? The 3's cancel. Now, do 2 and 4 have a common factor? Tell me something that'll go into 2 and 4.
1 and 2.
2. 2 goes into 2 once. 2 goes into 4 twice. 1/2. Did you guys never learn how to do that?
No.
Seriously? Oh my God. Oh my goodness. Well, we just got to do this. You just got to do this. Oh my goodness. So that was y to the... All right. Z to the z? Z to the 3/2 times 2/3. Don't you dare tell me 6/6. Why? Because the 3's will factor out and the 2's will factor out. What are you left with? 1. Z to the first power, which is just z. Have mercy. Okay. I got to teach you people some stuff. Okay. Math is not as hard as you make it out to be. I promise.
I'd say that's not true.
Here we go. Here we go. E. Now, what have I told you to do when you have a fraction? Split it up. Split it up. Now, you do not have Alzheimer's. All right.
So I was thinking maybe you could do x.
Which is actually 3.
Look, you're going to do the numerator and you're going to do the denominator, right? Let's do the numerator. X to the 12th to the 1/4. When I raise a power to a power, what do I do to the powers? You multiply them. 12 times 1/4 is 3. So that's x. That's x cubed.
Y squared.
Because 8 times the 4th is 2. F. All right, here we go. A to the 1/3, B to the 1/6, over C to the 1/6, all raised to the 6th.
The a to the cube to the a to the 6th, you separate them and do them separately.
I can separate them, yes. A to the 1/3 raised to the 6th. A to the
Squared.
A squared. B to the first over C. Yeah. Yeah. Are you writing them down? Okay. Where are we? Okay. All right. We're almost done. Now, this we have already done. Two more important things to remember about exponents. Negative exponents. Right?
Scared whoever has a
Negative exponents are the reciprocals of positive exponents. Remember, if you got a negative exponent in the numerator, he ain't happy. So where's he go? To the basement, and he gets happy. If he's in the basement and he's unhappy, then he goes to the upstairs to get happy. Anything raised to the 0 power is
You're gonna make her have an anger.
have an anger. How do you do that?
Pretty easily.
How do you have an anger? Here we go. Number 1. You need your pencil in your hand. Okay. Now listen to me. You can do these problems 2 different ways. You can deal with the negative exponent first, or you can raise the power to the power first. It does not matter. You're going to get the same answer. I would raise the power to the power first. So let's talk about raising the power to the power. That's negative, hang on, we're going to do it short. Negative 3/4 times 8. Now, don't you dare tell me negative 24 over 4, I don't want to hear it. Do you see any common factor between the numerator and denominator? What else besides 2? 4. Divide this by 4. 1. Divide this by 4. What do you get? Negative 6.
Wow. So just keep quiet.
Wait, how'd you say it's 6 and 1? What? Wow.
I said, oh, 4 will go into both of those numbers. So I'll divide the numerator by 4, and I'll divide the denominator by 4.
Negative 2 times 2 over
So for the next one, you just add them.
Uh-huh.
Wait.
Now, hang on a minute. Go ahead.
I don't understand.
You don't understand what piece?
Put it there, John.
I'm not finished with that problem. I've still got somebody's mad.
No, but like.
Okay, listen. If you are not comfortable, turn around, Gavin. If you are not comfortable with what I did, multiply across, okay? And you see that you'll have negative 24 over 4?
But like, I get the 8 and 4 part.
Yep.
But how'd you get the 6?
Okay, look at this. How would you simplify this? You divide by 4, right? So, I'm just going to divide by the 4 right here.
Yeah.
8 divided by 4 is 2. 4 divided by 4 is 1. So negative 3 times 2 is negative 6, and 1 times 1 is 1. So it's negative 6 divided by 1. Negative 6. Is that better? Okay. Now, he's still mad. How do you make him happy? So what's he going to look like? 1 over y to the 6th. Does that say a to the negative 3 halves times a to the 3 halves? When you multiply like bases, what do you do to the exponents? You add them. What's negative 3 halves plus 3 halves? 0. What? Oh, you're killing me. What's a to the 0 power? 1. Look right here. No, it doesn't. There's no dot. Oh, a dragon eye. Oh, duh. Look, Hayden.
I see it now. Yeah, I see
Okay.
it.
Number 3. I can't read that. What's the first part say? R to the what? Negative 1?
There's not.
r to the negative 1. No, you're not. Okay. Now, do you notice that there are r's in the top and the bottom? And do you notice there are s's in the top and the bottom? So we got to do something about that. But do we do that first? What do you think we got to deal with first? This is a negative s. This is right here, negative. Thank you. I would not have seen that. Hmm? Yes. So I've got to take care of the parentheses first. No, it just means I hadn't seen it. I hadn't gotten there. By who?
You.
What?
You looked at the problem. You looked at the problem on her page.
Numerator. Let's take care of those parentheses. R to the negative 1 cubed. When I raise a power to a power, what do I do to the powers? Multiply. So that's r to the times s to the, is that 1/2 or negative 1/2? When I raise a power to a power, so what's 1/2 times 3? 3/2. Over r times s to the negative 1/2. All right. Well, let's hang on a minute. Let's hang on a minute. Let's take care of those who are angry.
We'll take -3 down there.
Well, what do I move down?
Switch to R.
So if I move him, where does he go? So what goes downstairs then? To the 3rd. So I know I'm going to move him downstairs. So it's going to be r to the 3rd. Does he stay home or is he angry too? He's chilling. So s to the 3/2, he's chilling. Let's go down here. R. Is he happy or is he angry? He's cool, so he stays where he is. This s to the negative 1/2. Happy or angry? Move or no? So if he moves, what's he become? To the, all right. Oh. When I multiply like bases, what do I do to the exponents? Add them. What's 3/2 plus 1/2? 4/2, which is 2 s squared. No. When I multiply like bases, what do I do to the exponents? Add them. 3 plus 1. So that's r to the 4th. Yeah. Listen, one step at a time. Don't look at it and get overwhelmed. Just take one piece at a time. You don't like this. Okay. All right, number 4. Now, see, I didn't see this negative here. Okay. I got a fraction. Separate them. Do them separately. You can just separate them mentally. When I raise a power to a power, what do I do to the powers? Multiply. What's negative 1/4 times 4? Negative 1. So it's going to be m to the negative 1 over n to the, is that 1/2? 1/2 times 4. Are we finished?
No.
Why? The numerator has to be 1. Yeah. Because if nothing else is upstairs, there's a 1 there. I want you guys to try 5 and 6. I'm just going to walk through these. Guys, remember 8 to the 1/3 power means cube root of 8, which is 2, right? Then you have, is that that's an exponent of a third. X, y squared over, what's that say? Are any of those negative? The 6 was negative, so that's negative. Is the 9 negative? So z to the -3. So you should have what? 2x, the y squared goes down here and the z cubed goes up here. This one, any negatives? Because I can't see.
-1/2.
That's all? So that's r to the -2 s cubed over t, right? So that's okay. All right. Where's her practice page? It's all right. It's all right. It's all good. Go to that practice problems in the back. Let's pick. Let's pick 2 of those. Let me see. Who am I going to pick? Tori, pick one. I'm sorry, number what? Number 4. All right, number 4. X to the 1/2. Number 4, y to the -3/2 over z to the 5/2, all raised to the 2nd. Okay, then. X to the when I raise a power to a power, what do I do to the powers? Multiply. So 1/2 times 2 is 1. So x to the 1st, which is just x. Y. What's -3/2 times 2?
-6 over 2, or if you just get the -3 out of that. Because you do it.
Over z to the 5th. I can go with that. Are we finished? So what's it going to look like? What else is in the numerator besides x? Whoops. All right, let's have a look. We've taken care of that. Is he happy or does he need to move? He needs to move. Is he happy or does he need to move? He's happy. How's that? Okay. Let's pick 1, 5 and 6. I think 5 as well. There's one thing in number 5 that I need you to pay attention to. Let's look at 5. Let's see how we do. Say again? Yes, ma'am. It's exactly the same. Exactly the same idea. Yep, that's what I'm after.
So 27.
Boy, there's a lot of stuff here. 27x to the 6th, y to the 9th over z, x to the -3, y to the 12th, all raised to the 1/3. Have mercy. Now, Trent already figured out why I picked this one. It's because I got that 27 in there. What do I do with that 27? Not going to make it 9. I'm going to take the cube root.
Oh, 3.
So what's the cube root of 27? 3. X to the, good, x to the second,
Oh, yeah.
over z to the what? No, z, take care of z.
Right, so
So take care of z. Z to the
first power.
1 times 1/3.
Let me see the 1/3.
Trey. Right here. This 3 comes from 27 to the 1/3 power. And remember, no, it's 27 to the 1/3 power. Remember, that means the cube root of 27 to the first power, which is 3. All right, so let's go back and finish this one up. X to the what? I didn't want that to be purple. Where did you get -1, Hayden?
I did -3 times 1, -3 over 3.
There you go. There you go. -3 times 1/3 is -1. Y to the 4th. Now your question is, self, am I finished? Who do I need to deal with?
Really, just the bottom.
Okay. I need to deal with this.
Yeah.
So that's going to be 3x squared y cubed times x to the first over z to the 1/3 times,
So would you combine the 3x and the x? Or would you just leave it
3x and the x.
3x squared and x?
I'm going to combine what's x squared times x. So that's going to be 3x cubed
And y is it?
y cubed over,
So would you then do the y's?
now I've got y's in the top and the bottom. Now look right here. How many y's are in the top? 3. How many y's are in the bottom? So
Well, there's like
1 left in the bottom.
That's so none in the top, but 1 in the bottom.
So 3, that's correct. 3x cubed over z to the 1/3 times y. Guys, if you look at this at the beginning and think, oh my gosh, just do one thing at a time. One thing at a time. Do you want to do number 6 or do you want to call it good? Number 6. Okay. Anybody else wanting to call it good, or you want to work and throw it to number 6? Okay. For those of you who are wanting to walk through number 6 with me, let's go ahead and do that. Look at the numerator. Is there anything I need to deal with in that numerator? What do you see? Parentheses. Yeah. So y to the -2 squared is y to the -4. So this is going to give me x to the 2/3, y to the -4 over all that business. Did I write that down right? Yeah, I did. Oh, then wait just a minute then. I ought to be able to do this. Don't I have like bases?
Yeah.
When I multiply like bases, what do I do to the exponents? Add them. What's 3/4 plus 1/4? If I have 3/4 of a cup and I add another 1/4 of a cup, I have a whole cup, so it's 1. So that's going to be z to the first, or just z. Well, that looks a lot better. I'm going to get -4 downstairs, that's for sure. So I'm going to have x to the 2/3 over y to the 4th, x to the 5/3, z.
Well, then you have like 2/3 and 5/3. 5/3.
Because I've got x's in the top and the bottom, right? Now hang on, hold your little horses there. When I divide like bases, what do I do to the exponents? Subtract them.
3/3 is 4 whole.
But, all right, now listen. If I do 5/3 minus 2/3, I'm good that that's 3/3, which is 1. But does that x to the first stay in the numerator, or does it stay in the denominator? Why in the denominator? Because 5/3 was bigger than, because 5/3 was bigger than 2/3. So this is going to be 1 over y to the 4th times x times z. Say again? It did. It did look hard. You have 35 minutes. You have a front and a back. I'm going to put the answer key out, and I'm going to post the answer key to Classroom.